View results are the type of action result that you'll probably work with the most in an MVC application. In some ways, they are very different from the other action results. View results utilize a few other important components to render out a response to the request, most notably the view engine. The view engine is a special class responsible for finding and rendering our views. MVC currently provides two view engines by default, the Razor view engine and a legacy engine that uses an older ASP.NET syntax style. Now, this course is about the request lifecycle, so we are not overly concerned with a specific view engine implementation. When necessary, we'll use the Razor view engine to highlight a few specific points. However, we will mostly treat the view engine as a more generic component and focus on its role in the pipeline, which we'll discuss more in a moment. Like any other action result, the view rendering process begins when the action invoker calls the execute result method on that object. In the case of view results, the execute result method is actually defined on a parent class called viewResultBase. So the invoker calls the base class's execute result method, which in turn calls an abstract method named findView. The child viewResult class overrides this method and uses it to ask the view engine to find the right view. The view engine returns a view engine result, which will contain either the acquired view or a list of locations that it tried to search for one. Views are nothing more than a class that implements the iView interface, which defines only one method that's called render. Render is the method that finally writes out the contents of our template to the response for the request. If we look closer at the view engine, we'll find that it's yet another component implemented through an interface. iViewEngine defines three methods: findView, findPartialView, and releaseView. The first two methods are the most important for our discussion. These are the methods that locate a view file to be rendered. These methods are also what help to implement some of the MVC framework's great naming conventions. Let's look at how this works. So by default, the Razor view engine looks for views in these locations. There's also a duplicate set of these search paths for views that end in a Visual Basic file extension, but I've just omitted them here for readability. I've highlighted some placeholders in orange, so 0 represents our action name, 1 represents our controller name, and 2 is our area name if you happen to be working with areas. These placeholders are populated based on our route data. If an appropriate view does not exist at one of these locations, that's when we get an error list with the locations that were searched. You can change the locations that the view engine searches by either building a custom view engine or just extending an existing one. One other important aspect of view engines is that multiple implementations can be registered at the same time for a given application. They are utilized in the order that they're added to the view engine collection. As soon as one of them finds a view, the search is finished. The other view engines are never used for that request. So for example, if our application has 3 view engines registered, if the first view engine can't find an appropriate view, the framework will try the second one. If that view engine does find a view, the third will never be utilized for that request. You can register view engines and change their evaluation order using the static view engines collection in your global.asax file. Let's return to the MVC source code for just a moment to complete our source code examples. I have open our action invoker from a previous lesson where we looked at the invoke action result method. Let's revisit this from the standpoint of a view result. Now in another tab, I have open the viewResultBase class, which inherits from action result and overrides that main execute result method. In this method, you can see the framework first checks that it has the right context and information available. A bit further down, you can see where this class calls the findView method. This is the method that will use our view engine to locate a view for us. After a view is acquired, next this class calls the render method of that view. This is the point at which the response will be generated and written out. Now in a complex view engine like Razor, this rendering process is pretty involved under the hood, but the important thing for now is just to understand when these steps happen in the request lifecycle. The findView method that I just pointed out a few lines up is actually an abstract method which is overridden by the viewResult class. If we open that up in another tab, we can see what's going on. Inside of this method, the framework calls another method named findView on the view engine collection. This method basically just loops through all the view engines registered with the application and asks each of them to find the right view. You can see we're getting a view engine result back. If there's a view attached to it, we return that. If there's not, an exception will be thrown that prints out the list of places that were searched. In the next lesson, let's look at an example of how we can customize where the view engine searches for views.